Hey guys, welcome back. I'm Miss Danielson, and today I'm taking you through a lesson on base 10 multiplication and division. Now, if this is your first time with us, let me just explain how this works. First, I'll take you through a lesson, including some theory and some examples, and then I'll leave you with a pause and practice exercise with the answers taken up at the end. If you weren't with us for our lesson on place values, you may want to check that out first, so I'll link that lesson down in the description box down below. Before we get started, this title page was brought to you by Camilla from last year's Year 7s. Thank you, Camilla. So what we're going to be looking at today is what base 10 numbers are, which will involve some basic exponential knowledge, which is something that's probably new for you if you're Year 7 right now. And we will be able to multiply and divide by any base 10 value. Now, this is something that I would expect most of you are already able to do. It's just a bit of revision. First of all, what is a base 10 number? Well, here are some examples of base 10 numbers. 10, 100, 1,000, 10,000, 100,000, a million. Surely I don't need to go on. You can see the pattern here. These values are called base 10 values as they are the result of multiplying tens together repeatedly. So for example, 10 is just one set of 10. But 100 is 10 times 10. So that's multiplying 10 by itself, or multiplying two tens together. 1,000 is the same thing as 10 times 10 times 10. So that's three tens multiplied together. And 10,000 is 10 times 10 times 10 times 10. That's four tens multiplied together. Notice the number of zeros in 10. It's just one zero. It's just one 10. Notice the number of zeros in 100. There are two zeros there, and it's the result of multiplying two tens together. 1,000 has three zeros, and we get it from multiplying three sets of tens together. And 10,000 has four zeros, and we get it from multiplying four sets of tens together. Note the pattern? Pretty simple, right? Another way that we could write this is saying that 10 is the base, and the exponent, when it's just one 10, well, we don't need to put it, but it would be a 1. For 100, that's two tens multiplied together, so we could write 10 as the base, and the exponent, or you might use the word index or power, is 2. Note the index matches the number of tens being multiplied together. It also matches the number of zeros that there are in 100. So for 1,000, that would be a base of 10, and what would the index be? I hope you said 3, because it's three zeros in 1,000, and it's three tens being multiplied together. What about 10,000? That would be a base of 10 and an exponent or index of 4. If you were with us last lesson on our lesson on place values, you'll remember that we talked about our place value system being based on jumps of 10. Because there are 10 digits, so once you've gone through all 10 of those digits, we need to move up a place value. Multiplying by 10 moves all of the digits up one place value. Or, if it's a whole number, we could put a 0 at the end of it. For example, 12. 12 has got a 2 in the units position and a 1 in the tens position. And if I do 12 times 10, that gives me 120. That has moved all of my digits up one place value. The 2, which was in the units position, is now in the tens position, making it worth 20. And the 1, which was in the tens position, is now in the hundreds position, making it worth 100. The digits are now worth 10 times as much, and they've all just moved one place value up. To make this simpler, you probably just think, I'll put a 0 on the end of it. And that's fine, so long as it's a whole number. How about for decimal values? When we've got a decimal value and we multiply by 10, that decimal point is going to move to the right one place to make our answer bigger. If you get your lefts and your rights confused, just remember that when we multiply by 10, our answer should be getting bigger. So 0.014, or 14 thousandths if you prefer, has a 1 in the hundredths position and a 4 in the thousandths position. If I were to multiply this by 10, all of my digits are going to shift up one place, or my decimal point is going to shift one place to the right, and we're going to end up with 0.14. or 14 hundredths rather than 14 thousandths. Now I've got that 1, which was in the hundredths position, in the tenths position, and the 4 that was in the thousandths position is now in the hundredths position. But I'm sure from mental calculation, it's a lot easier for you to remember. Move the decimal one place. If I'm multiplying by 10, my number should be getting bigger. So that'll help you remember which direction to move your decimal in. Now, when we're dividing by 10, we can use the same sort of rule. When we divide by 10, we shift all of the digits down one place value. Or just consider that your whole number is getting smaller by one place value. In whole numbers ending with a 0, we could just take off a 0. But if the number does not end in zeros, we're going to need to put a decimal place in front of that last digit. Here's another example. So for 145, that does not end in a 0, so I can't just take off a 0. If I divide this number by 10, I'm going to move all of the digits down one place value. So I used to have a 5 in the units. Now that 5 is in the tenths position. The 4 that was in the tens position is now in the units position. And the 1 that was in the hundreds position is now in the tens position. Or, like we said above, it was a whole number, it did not end in 0, so we just need to move the decimal in front of the last digit. What about with decimal values? With decimal values, you will already see there is a decimal there. And when we divide by 10, we need to move that decimal one place to the left. If you're like me and you get your lefts and rights confused, just remember when we divide by 10, we want our answer to become one place value smaller. That might help you to remember which direction to move that decimal point. So for 3.4, for example, if I divide that by 10, the 3, which was in the units, is now going to be in the tenths position. And the 4 that was in the tenths is now in the hundredths position. Or, more simply, I've moved my decimal point one place to the left. So my whole number is one place value smaller than it was before. Shifting place values. That's all we need to do when we're multiplying or dividing by base 10 values. Since 100 is the same thing as 10 times 10, or 10 squared, when we multiply or divide by 100, we shift all of our digits to place values. Look at the number of zeros in 100. It's got 2 zeros. That will remind you 2 place values. Similarly, since 1,000 is the same as 10 times 10 times 10, or 10 to the power of 3, when we multiply or divide by 1,000, we just shift all of our digits 3 place values. Again, note the index. 10 to the power of 3, I move my digits 3 place values. When I'm multiplying, my number gets bigger, so think about which direction that would be. And when I'm dividing, my number gets smaller. So again, that will help you to remember if we're moving our decimal to the left or the right. Are we putting on zeros? Are we taking off zeros? Which direction are we going here? Here's a little bit of an extension for you. Now, this is not strictly Year 7 material. However, sometimes it comes up when your calculator does stuff like this. This is something we would usually see at Year 10. 2.1 times 10 to the power of 10. This is called standard form, and your calculator sometimes does this when there's not enough space on the screen to write the whole number out. But we now know that when we multiply by base 10 numbers, we're just changing the place value. This time, I need to change the place value by 10 places. And I'm multiplying by 10 times, which means this number is going to get bigger by 10 place values. So I'm going to move that decimal point 10 places. That means moving the decimal place from where it is to after that 1, that would be 1 place. I've got 9 more to go. If I need to move it 9 more places, I'll fill those places in with 9 zeros. So here we've got our answer. Remember, our decimal was here, and I've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places all together. So now it's invisible, hiding at the end of the number. That would be 21 billion. Now, as I said before, this really isn't year 7 material, but if you see it come up on a calculator, now you have an idea of what to do about it. Let me show you another one. If your calculator says something like this, 5.7, and then you have a tiny little 10 there and a little -4 above it. Let me write that how we would write it, not how the calculator writes it. This means 5.7 times 10 to the power of -4. And multiplying by 10 to the -4 means that we want to move the place values, but in the negative direction. So the opposite direction from what we would usually do when we multiply by 10. When we multiply by 10, we usually make the number bigger, shifting all place values to the left. So this is basically saying, make the number smaller. So it's the same as 5.7 divided by 10 to the power of 4. 5.7 divided by 10 shifts all of our place values to the right, making our numbers smaller. We want to make this number smaller by 4 place values because the power is 4. So I'm going to move that decimal point 4 places, making this number smaller. So that's going to be 1 place to move it in front of the 5, and then 3 more places to make 4 altogether. Here's my answer. Remember my decimal point was here? And I've moved it 1, 2, 3, 4 places. Like I said before, this is extension work, and I'm happy to discuss it with anybody, but if you're not quite clear on it, don't worry about that for now. Let's just go on to practicing what we do need to know this year. So here's your practice exercise. First, I want you to multiply each of these values by 10. Next, we're going to multiply each of these values by 100. Then we'll multiply these values by 1,000. Then divide these values by 10. Divide these values by 100. And divide these values by 1,000. Go ahead and hit pause. Remember to copy the questions and show you're working. And push play when you're ready to see the answers. I hope you had a chance to hit pause because here come your answers. For the first row, multiplying by 10. For the second row, multiplying by 100. For the third row, multiplying by 1,000. For the fourth row, dividing by 10. For the fifth row, dividing by 100. For the sixth row, dividing by 1,000. Now, I hope you found this lesson and this practice helpful for you. If I've left anything at all unclear or you want to discuss standard form, please leave me a comment down in the comment section. Otherwise, keep practicing and I'll see you soon.